I want to welcome everyone to InRoads Intersection Design XM Edition. This morning we're going to talk about designing intersections with InRoads XM. And what we're going to cover is we're going to create a simple T intersection. And when we create the T intersection, we're going to add the radius returns and have it automatically create vertical alignment. Once we do that, we're going to update our design within the Roadway Designer with point controls. After we assign the point controls, we're going to refine the model creation with target aliasing and corridor clipping. Once we do that, we're going to create a DTM with a merged model of the intersection, thereby demonstrating the capabilities of corridor clipping. Once we complete that, then we're going to take an intersection, a typical skewed intersection, and I'll demonstrate one technique on how you can accommodate the component design within the Roadway Designer with a skewed intersection. So with that said, let me go ahead and swap over to my InRoads program and give you an overview of the project we're going to be working on. The first intersection we plan on designing is the one right there, which is relocation 2 of Highway 278. Now this has already got the horizontal alignment defined, and I've already created the vertical alignment. When I create the vertical alignment, I've already processed the mainline roadway, and I processed it with the Roadway Designer, and I had it create the surface. Once I've created the surface, I cut the profile and I wind up with accurate pavement elevations that I know where I need to tie to. Okay, I have assumed that everyone knows how to run the Roadway Designer, how to create a corridor, and place a template within the corridor. I've also defined the superelevation for this side road corridor. So these pieces have already been completed within the design. I'm going to go ahead and select Process All, and you will see that the intersection does not contain any radius in there. It's just a standard template with the normal lane widths. Now this is always a problem in computing intersections and creating intersections, especially in an instance such as this, where you have not only a vertical curve that ties into the main roadway, but you also have superelevation going on along the side road. So the side road has superelevation and is also in a superelevation transition. So instead of going in and computing these pavement elevations manually, we're going to let InRoads compute this information for us. So how do we accomplish this? Well, I'm going to begin by creating some surfaces. So I will select the Create Surfaces button at the top of the Roadway Designer. And then I'm going to select the corridors that I wish to create the surfaces. So I'm going to go ahead and apply and let it create the surfaces for the two corridors of the intersecting roadways. Notice that when I created the surfaces, I had the Densify buttons turned on. for those of you who do not know, the Densify buttons will compute a more accurate pavement elevations based on horizontal and vertical curves. The settings that control the density of the template drops are controlled within the Tools options within the InRoads main menu. Those settings are controlled there. So let me go ahead and I'm going to close the Create Surface dialog. I'm going to minimize my Roadway Designer. I'm going to set a feature selection filter to only show me the finished grade features within the model. Now I will proceed to the Surface Update 3D Plan display, and I will display those features. Apply the command. I had a failure. I'm currently running a Service Pack 1 work in progress build, and because of that we've got a few issues we have to work out before we do delivery. So I had a failure button, but as it is the case that most users find that there's more than one way to do things within InRoads. So I went ahead and I went to the Surface View Surface Features command to go ahead and display the features. So those of you who saw the failure button, I apologize, but we're working on Service Pack 1 and we're hoping to have this out very soon. And by the way, that failure dialog will not show up. So what I'm doing now is I'm picking up my model and rotating it. So you can see that what we want to do is we want to tie this pavement elevation in to the mainline pavement elevation. And similarly, we want to do the same thing with this edge of pavement and have it tie in with the radius return around to this pavement elevation. Now recall, we're in full super elevation across the main roadway, and we're also in a super elevation transition along the side road. So I'm going to go back to a top view and fit the graphics. And I'm going to immediately go in and create the radius returns. I'm going to use geometry to create these radius returns because I'm going to use the geometry as my control lines for my Roadway Designer point controls. So I will select Geometry, Utilities, Multi-Center Curve. Notice I already have a preference set that has my standard radius and my standard pavement widths already defined. If you need to change those, you can always key those in. But here's where the trick comes in on creating these radius returns. If I select the Advanced tab, I can create not only the horizontal alignment, but I can also create a vertical alignment. Notice the checkbox. We have multiple options for creating the vertical alignment, but the first two options don't work too well in this instance because for for example, we're in a transition in superelevation, so we don't know the gradient or the vertical distance. So instead, we're going to tell it to compute from a given surface. Now the surface you select is critical at this point. Because the prompts look for a first selected alignment and a second selected alignment, you have to make sure you have the correct surfaces selected in these combo boxes. So now when I hit apply, I select the main line, center line 278, as my first alignment, and I select the side road as my second alignment, which is also the second surface, and I identify the quadrant for the return, and I accept. Now I want to repeat the process for the other quadrant. So I identify the quadrant and accept. And I'll reset out of this command and close the dialog. Now let's very quickly verify what we've done. So I'm going to create a profile. And I'm going to go ahead and create it along quadrant 2. I will select the two surfaces, select apply, close the dialog. Notice we have our surface lines for our two roadways. When we created our radius return and had it create vertical, it actually goes in and creates true vertical geometry. There we go. Creates true vertical geometry that ties in from edge of pavement to edge of pavement, which is for the beginning and end of the radius return. If I use vertical annotation, you'll see that it actually contains a vertical curve. It also provides your low point. You can adjust this vertical alignment, so you can force a low point where you want it, for example in an urban condition. So I know now that I have good vertical, and I'm going to leave the vertical alignment as designed by InRoads. So now let us return to the Roadway Designer. I'm going to reset my active surface to existing. And I'm going to add these radius returns into this roadway corridor. How do I do that? Well, I do that via the point controls. So I select the point controls button, we select the point we wish to control, at this point I'm going to use the left edge of pavement, the right edge of pavement, and I want it to be controlled both horizontally and vertically. Another thing that we want to make sure of is that we want to turn on the Use as Secondary Alignment checkbox. You will see when I create the model that this is critical. Now I need to select the correct horizontal alignment. Well, I can't remember what name I provided, so I'm going to hold down my Control key and hit the Select button. And I'm going to select the alignment that I wish to use. Now I can add that control. I want to repeat that process for the left edge of pavement. Select the point from the template. Select the radius return I wish to use. And I'm going to add. Now notice how the color changed on the point controls. This is a visual cue to you, the user, that there is something in conflict within these point controls. Well, if you notice, we have superelevation point control, which is in actuality a vertical point control, and we also have a both point control, which is both horizontal and vertical. Well, once we get to the beginning of the radius return, we no longer will be using superelevation. We'll be using the radius return as our vertical control. So what I'm going to do is I'm going to limit the stationing of the vertical superelevation. Alternatively, I could change priority. If you notice, they're all set to priority 1. I could change the superelevation to say I'm a priority of 2, which means that if I find another vertical point control that has a higher priority, process it instead of superelevation. But I'm going to choose to change my stationing of my superelevation. So instead of keying in, I'm just going to hold down my Control key and go out here. And snap to the point and change my stationing. Notice they're no longer orange. So now I'm going to close my point controls dialog. And notice how the plan graphics have changed within the Roadway Designer. We now see our radius returns, and they're in a specific color which indicate that these are secondary alignments. So if I process along this corridor, you will notice that once I get to my point controls that are secondary alignments, my cross-sectional view changes as well. For those of you who don't know what a secondary alignment is, you will see that as I progress into these secondary alignments, you'll notice that my processing skews orthogonal to the secondary alignment. And what that will do is that will permit a proper grading along my side road to where my slopes will tie in to my main line. So now all I have to do is go in and assign my target aliasing that clips the two corridors to make a merged model. So if I go to Tools, Target Aliasing, I want to target, in lieu of the active surface in condition target, I want to target the main roadway corridor and the existing surface. Notice that my corridor, the mainline corridor, is the highest priority. That's because I wanted to look for the corridor first and then look for the existing surface. If I have a long list of aliases, I could use the use closest, or I can change the order, move up, move down. So once I have my aliases selected, I can select OK to close my target aliasing dialog. If I go back to my centerline 278, reprocess that corridor, swap back to my relocation number 2, you will see that we wound up with a processing alias dialog. It was very quick, but what it is doing at this point is it is processing in memory a fictitious or a pseudo surface of the main line. Now I'm going to process all on this side road. Now notice, as I progress through, once I get to the surface, there's my corridor of 278. And you can see that it ties in nicely. So at this point, I'm going to give it another shot with this Update 3D Plan display. And turn off all the features. I'm going to go back to my Roadway Designer, and I'm going to recreate my surfaces. But this time, instead of creating a new surface for each corridor, I'm going to create a merged surface of multiple corridors. I'm going to give it a name. I'm going to call it Model. I'm going to select my corridors, and then I'm going to my clipping options. And if you'll notice, relocation 2 is clipping the main line, and the option is to clip all. That is what I want. There are multiple options within this dialog. Clipping conditions, and now with Service Pack 1 we have a clip none. This will be useful for those of you who are doing interchanges and are getting into some advanced modeling techniques and you don't want it to actually clip. So I'm going to leave the side road as clip none for now, and I'm going to go ahead and leave clip all for relocation 2 versus the main line. Now before I create this surface, I'm going to have it add transverse features just truly for a visualization process, and I'm also going to tell it to display the features in plan view. Recall that I had a filter set that will only display the features of the finished grade, not all the additional non-triangulated features that control the components. So I'm going to hit apply and hold my breath. and it's going to create our surfaces. I'm sorry, our surface, because we're creating a merged model at this point. For those of you who don't know, the new surface for each corridor checkbox, it will ignore the clipping options and will process a corridor as if it was standing alone. This will enable you to create multiple surfaces at once, and it will use a surface name that equals the corridor name. So let's close this dialog. I'm going to go ahead and I'm going to save this right now. I'm going to minimize my Roadway Designer, and let's look at our results. As you can see, I have some transverse features going on, and I'm going to once again rotate the view, leave it in dynamic mode, and let's pick it up, take a look at what we wound up with. As you can see, we have a pretty good model going on here. Looks like my ditches are flushing in pretty well. I'm going to go back to a top view and give you a little tip on what I have done to create this. Zoom in. Now notice that I did not take it all the way to the edge. I stopped this corridor at the intersecting point of the, or just shy of the intersecting point of the edge of pavement and the side road. The reason for this is that I want to make sure that I maintain the integrity of the edge of pavement feature. Now we want to do this because I want to make sure that as long as this feature exists for the edge of pavement, I have got components for the pavement. Now of course that causes, because this is in a horizontal curve, that causes a little bit right there to be shy. Okay, but we're talking about 6 inches horizontally. Vertically, we're tied in. Your triangles are going to be tied in. Your surface model is going to be good. So now let me go in and I'm going to update the display again, and this time I'll turn off all these features. Fit the view. And now we're going to talk a little bit about this skewed side road. The skewed side road design, I already have my radius returns defined with the vertical, which I outlined in the previous process, and I've already added those as point controls to the roadway design corridor. The problem you run into, however, is the fact that when this point control ends on this western quadrant, the typical section drops back to a normal typical section, which would be a 12-foot lane width, and would continue in to the main roadway. Well, what we're doing here is we're attempting to maintain the integrity of the components up to the edge of pavement. So I've developed a little technique that I find to be very easy and very quick for modeling these skewed intersections and maintaining the component integrity. So let's take a look at that. I'm going to change over to the side road corridor, and immediately you will notice that I already have my secondary alignments. And I already have my vertical defined and my template. If I go to my manage corridors, you will see that I have an end station limit that is not actually the end of the vertical alignment. I am stopping at roughly the end of that radius return. So I'm going to back it up about an inch. So if we look at this from a standpoint of what gets built once we get past the end of the western quadrant radius return, you'll notice that once we get past that point, we no longer are going to build our slopes and our shoulders. So what I'm going to do is I'm going to my template drops dialog, and I'm going to go very quickly go in and make a copy of this template. So I select the template, I hold down my control key, I'm going to go out here to the graphics, and I'm going to drop a new template right there. And I may want to change my interval. I'll put in 2, and I'll select add. So now I'm going to edit this template. At this point, I am editing the template directly in the Roadway Designer. This will no longer be the same as the template that is shown in your template library. So if I right-click Delete Components, draw me a little line around here and squiggle and say, that's what I want to get rid of. And say OK. So now if I progress through my design, once I get to that radius return, past that radius return, I should not have any shoulders. And that's true. But let's take a look at our plan view and see what happens once the edge of pavement crosses the center line. Well, at that point, we're not building a left edge of pavement. Right in here, we're going to have a left edge of pavement template. At this point, we're going to have a center line only. So I'm going to come back to my template drops, select the same template that I just edited, which is denoted by the IRD. That's your visual cue. This has been edited directly in the Roadway Designer. Hold down my control key, select, and I'm going to snap to the intersection and I'm going to back it up just a little bit. Let's say about an inch. And I'll say add. So let's edit that template. Once again, right-click Delete Components. And now I need to get rid of my left edge of pavement points. So I'm going to very quickly go in and repeat the process throughout. Notice that when you have a shared point between two components, you have the opportunity to select which component. Very quickly I'll delete those and say OK. So now as I progress along, you'll see that I have a left edge of pavement, and then it'll drop down to just a center line. So I'm going to close this and look at the plan view. You can see that I wind up with standard left edge, and then it pops over to a center line. So now what I want to do is I want this to clip off correctly in this area, and I'll do that with point controls. And once again, I'm going to use a both control. I'm going to select my left edge of pavement, but this time instead of an alignment, I'm going to use a corridor point. And the corridor point is going to be from the mainline corridor, and the point that I want to target is the right edge pavement. So I need to set the limits. So I'll go back out to my graphics, and crazy enough, I've somehow managed to flip my DGN upside down. Not like none of us have ever done something crazy like that before, huh? Let me pop back over here to my view rotation and go back to a top view. Oh yeah, that looks a little bit better. I'll go back to my Roadway Designer. And let's try this again. So I'll go get my station limits. And what I'm going to do now is I'm going to provide just a little slight offset. And I'm going to add. Now all I have to do is repeat the process for my centerline point. Once again, it's a corridor point. It's going to tie to the right edge of pavement. And this time I'm going to go ahead and just copy and paste my initial statement, my initial station. I have a little bit of a problem with our live meeting is taking over my view control. Let's go get that station that we need. I'm going to leave the horizontal offsets, select Add. So now if I do a process all, notice how the corridor is clipped along the edge of pavement. But I'm just shy of the edge of pavement. That's because I'm attempting to maintain the integrity of the features that control the components for the mainline paving. So let me finish this up by going in and making sure that I have my target aliasing taken care of. And I'll tell you what, let's just go ahead and I'll progress through here and you'll see what we have going on. Notice how that left edge of pavement is getting narrower and narrower, and then now my center line is controlling down to nothing. I hope everyone sees that. So let's go in now and let's create some surfaces. But recall that I changed my clipping options to none, but we wanted to do clip all. So let's say OK. I'll just go ahead and I'm going to give it a new surface name. And let's go ahead and run it. See what happens. Once again, I'm creating an overall merged model. There are mechanisms to create each one of these clipped models individually, but we'll save that for another day. So if I did everything right and I'm living well, hopefully we'll have a good model once this thing's finished creating its surface. Now notice this is taking a little time, but you know you can always do a process visible range only, which is a selection down at the bottom of the Create Surfaces dialog. And what that's going to do is that's going to only process what you see in the plan view. This will greatly restrict the amount of data that you're having to deal with. Now I can see right off the bat that I may have a problem right in here, but it's quite possibly not. And also you can see over here that we might have some issues going on. Of course, I forgot to select the Remove Loops option, which tries to rectify those and correct those problems. But there may be some small amount of end condition type of overlap that you may have to edit. So let's take a look at our results. So I'm going to minimize my Roadway Designer. And I'm going to zoom out a little bit. And I'm going to pick up my model once again. I don't know how many people out there do this, but this is really a good way to check to see, does everything look all right? And as you can see, I'm real close. I'm probably within, very small amount there in my ditch. I would have to verify what's going on here, but what I would suspect is that I have a rollover lock on my side road shoulder, and I don't have anything applied to my mainline shoulder has a rollover lock, and my side road shoulder has nothing to control it, so it's using a standard 4%, and I have a little differential here that may need to be dealt with a separate control. Looks like I have a little bit of editing going on right here. And of course, my remove loops may take care of some of that. And here's my other intersection that we worked on. And so that's about all I have for this particular instance of the Institute Civil Lecture Series. Let's talk about a little bit about what we've done. Well, I modeled an intersection, and the first model of the intersection I did without surface feature editing. And I used the horizontal point controls and also used them in conjunction with secondary alignments to create, an accurate model around a radius return. I took target aliasing and corridor clipping, and I used it to generate a model that is combined and removes the mainline pavement that you don't need. And then I demonstrated a method of modeling a skewed intersection with minimal feature cleanup. And that's the end, and this concludes of my InRoads Intersection Design XM edition.